Welcome to Excel Labs video number 8, Investment Appraisal. In this demonstration, we're going to have a look at net present value, the internal rate of return, and the payback period, and how you can put up a model in Excel to actually have them calculated in Excel. Before you proceed, make sure that you have the instruction sheet available, which you can download from Moodle, as well as the Excel file named Excel Labs Video 8 Investment Appraisal XLS open. It's important that you familiarize yourself with the questions asked on the instruction sheet before you continue following this demonstration. Now let's have a look at this example. The outline's looks quite short. Spring Experience is planning to purchase a new window cleaning machine for skyscrapers. You have been asked to prepare a simple analysis to determine whether the machine should be purchased or not. The machine costs £15,000, has a useful life of 5 years, and an estimated residual value of £10,000. The estimated annual net cash flow from the machine for years 1 to 5 are, as laid out. Spring Experience required rate of return is 9%. Now we want to have a check. What's the payback period? What's the machine's net present value? And what's the machine's internal rate of return? And then ask the question, should Spring Experience answer purchase the machine, why or why not? So make sure you have this Excel sheet open right here. Again, we have the main headers already there. We're just adding today's date. So today, call up the today function. Don't forget to open and close the brackets. Now this should not concern you. If this happens, it just says, Excel just tells us that this is too large for the cell. However, this will change in a minute because we're going to select all the cells in row number 4 down to column H and including. Click merge and center, and there you see this is today's date. Now, we're going to have a look at, first we need to construct the table. So if it helps you construct such a table, because there are many ways, and the way I'm showing you is just one of the many ways you can do this. So if it helps you, pause the video right now and try to calculate this on a piece of paper first, and then you can attempt to translate this into Excel. Okay, now let's continue with our example. First, we need to put in the data. So let's jump into row number 6. And first we need to determine the cash flows per year. So we first determine the years. Don't forget there's a year 0 where the initial investment will take place. 1, 2, 3, 4, and the useful life is 5 years. Column A, row 7. Initial investment. Row number 8, the cash flows. This means the ongoing cash flows during its useful life. Row number 9, the terminal value, which will occur at the end of year 5. In row number 10, we will have the full cash flows. We will see in a minute what that means. Then we skip one row. In row 12, we add the rate of return, where we fill this in a minute. Let's make this a bit larger, because as you can see, this does not quite fit in there. Let's make this look a bit nicer. So let's select all those cells, all the years. On the Home tab, in the font group, you have a little something called fill color. You can pick any color you like. We take yellow here for now and make this bold. and now we're ready to fill the table. Now the initial investment is 15,000. That's the cost, the initial cost of the machine. 15,000. Now we need to make sure to tell Excel that these 15,000 are actually a cost. Now you could do this in two ways. Either you determine this on the sheet in the numbers. So basically you tell Excel this here is a minus. Or you determine it in the formula. Now in this case, we like to make it, or we are going to make it visible that the numbers are negative. So in a minute I'll show you how. The cash flows are the next. So the first cash flow is minus 3,200. In year number 2 it's plus 3,700. In year number 3, 6,300. In year number 4, 6,550. And in year number 5, 5,970. Quality check, is it all there? Yes, and the terminal value occurs at the end of year 5, and it is actually quite high, 10,000. Well, we don't know the nature of that machine. Now, the full cash flows. Now for this row will be necessary in order to facilitate our application of the formulas we're going to apply, in particular net present value and internal rate of return. So this is why we created this column right here. This is basically just the sum of everything which is on top here. Press enter. Now all we do is copy this across. But this is the full cash flow, so to speak, including the initial investment and the terminal value. And now select the whole row here, or the whole area, from B7 down to G10, and now open the number format here. So home tab, number group, number. We're making this a currency or accounting. Let's choose accounting this time. Actually, currency is better because it has a negative number feature. So let's take currency. We don't have any decimal places. We select pounds. So again, if by default pounds is not your currency in Excel, then you need to open the list and select pounds. And now let's select the following. If the number is negative, we want it in red and indicating it with a minus. So that's what you just select right here. This is the last part you should select. Enter. And now you see what happens. The negative numbers are immediately indicated to us by making them or coloring them red. So we're in the red here and the numbers are black here, so that's positive numbers for us. So that's that prepared. Now the rate of return, as we know, is 9%, so let's just fill that in here. Don't forget the percent sign. If you just type in 9, it will not quite work. Yeah. So number 9 and percent. Alright, now we have everything in place in order to calculate our investment appraisal. We should start with the payback period. So let's skip one row and jump into row 14, payback period. Now how would you do that on a piece of paper? You would go, basically you would start with the initial investment and see when the cash flows, the subsequent cash flows, are able to balance that initial investment. So let's factor this investment in right here. That's the initial investment, and that happens in year 0. So this is an ongoing number on the side. You should take with you. Let's move a little bit up here. And now we need to determine that the cash flows are filling up this initial investment. So we add a little formula. We add this and the subsequent cash flow to it. So this, now plus this. Now this would happen at the end of year number 1. Now what happened at the end of year number 1? Well, to the initial investment of minus of 15,000, there was a negative cash flow which actually increases the negative number. So there's even more to catch up on. We take the 18,000 plus the 3,700 in year number 2. Now this looks much better. Now it's down to 14,500, year number 2. 14,500 plus year number 3, 6,300. That will be a big jump towards having it balanced. So that's year number 3. How about year number 4? 8,200 plus the cash flow in year number 4 is 6,550. So we earned that back. So it's year number 4. And now, before you do year number 5, you will find that the cash flow in year number 5 is much higher than, and we need to look at this cash flow, not the terminal value. Yeah, this does not count towards the payback period. 5,970, and obviously in the course of year number 5 there will be a break even, so to speak. Basically, we need to determine now when this will happen. We can just do this quite easily by logical thinking. We add to a formula, and now we are assuming that the 5,970 are evenly spread out over the year. That's of course just an assumption. In reality, it's not the case, but we're assuming that basically every day the same amount of cash flow comes in. So at the end of the year, we have a cash flow of 5,970. This is why we can divide this, the remaining negative cash flow, by the cash flow in the year where we expect it to break even. Now that's of course not a nice number, and also it's negative. So we want to use this number in order to determine when during the year we will break even. Now this is 0.27 years. Let's multiply this by -1. Make this positive. There you go. And now we need to determine, okay, how many months are that? Basically, we just multiply this fraction times 12. So we have 12 months. This results in 3.31 months. So that means that sometime during April in the 5th year, we will break even. Now we are content with just an estimate right now. Now I'll show you a neat little trick here. I'm going to determine a sentence based on the numbers right here. So I'm going to type, it takes about. Now make one more blank here and then enter a quotation mark. So make sure that in between here is a blank, as an empty space. And you enter an ampersand, and then you click on this number, add another ampersand, quotation mark, blank, type years, and another blank and quotation mark, so type it exactly as I put it out here, ampersand, months. Now these months here, if I would add or reference this cell, it would return 3.31 months. And say, okay, I want to round up. So I'm adding a round up formula. There's a new formula for you. The number is right here, so refer to this cell. Semicolon. And the number of digits afterwards, say 0. You don't want any digits afterwards. Just should take the round up and be done with the exercise. Close the cell. Ampersand. Quotation mark. Blank. Months to break even. Don't forget the quotation mark and enter it. Now let's have a look what we actually did. Well, we combined text strings and values from formulas and values in cell references in particular. So you always need to enter, or you need to open something like that with an equal sign. Then a quotation mark indicates, aha, this is now a text string. So the first text string reads, it takes about blank cell quotation mark. And then you add anything which is in a cell and not a text string with an ampersand. So you need to have an opening ampersand, if you want to call it like that. Refer to the cell you want to include in the text. Then ampersand again, because there's text following. If there would be no text following, you can just leave the second ampersand. A quotation mark, blank, because you need the blank between the numbers and the space. You would see that if you would have no blanks and pressed enter, you would see it would basically be one long text string. The next text string reads years ends, and then we want to refer to the number of months, but since this is not quite a nice number, you can either choose to round down or round up. I decided to round up in that case because during the month of April, during the 4th month in the 5th year, we will break even, and that's for us, that's close enough. Yeah. And then the third text string, months to break even. Now let's see if that worked. Press enter. There must have been some mistake in there. Yes, I forgot to close the bracket. So it's correct. That accepts the change that Excel suggests. So that's fine. Let's check this again. Yes, I've forgotten to close the bracket, so that's fine. I did an additional bracket too much, so that was the problem. Doesn't matter. Excel is very helpful, and so you see it says it takes about 4 years and 4 months to break even. Now let's change this just to see if this works. There you go. See, this would work. It changes the text, but it's 4 years, but 4 months. Now that's from a investment appraisal point of view, that's quite dangerous, because the useful life is 5 years. So this investment only breaks even in the 5th year. So a few months before the investment is actually over and done with. So that's quite difficult to actually apply. But let's have a look at the net present value and the internal rate of return. Now let's select row number 24, type NPV, and we open a formula in column B, row 24. Now Excel is quite helpful here because Excel provides a formula called net present value. So we type NPV. We open that. Now you see, you can actually open this here as well, so it's better visible. This is the dialog box. Now the rate of return is of course the 9%, so we refer to 9%. And Excel tells us precisely this is 0.09, so it's a percent, so that's fine. Now we type in the values. Now you could type in every additional value, but what we are going to do is we're going to select these values here, and now we need to be careful. If we selected this value as well, so if we would select the whole range here, we would have the problem that Excel would think that the initial payment happens in year number 1 and assumes that these are 6 years. So we need to do it a bit differently. We need to tell Excel, alright, this is the net present value. Then select the cell here, and now we add this value. And this tells us that the net present value is 5063. Now you can have a check if this is the correct number. So we took this row here, including the terminal value. We discount this using 9%. And we add the initial investment to it. Well, the net present value looks quite promising. How about the internal rate of return? Type IRR, and yes, there is an internal rate of return formula. Again, we use this. Now with the internal rate of return, we need to take the whole range in, because Excel needs to determine when does this return 0. So that's quite straightforward. Returns it in percent immediately. Let's add 2 decimals, and we find that the internal rate of return is 16.43, which is relatively high. Right, now we need to consider answering our question. Well, we have the payback period. We have the net present value and the internal rate of return. The internal rate of return is much higher than the actual rate of return, which is good. So this is consistent with the positive net present value. So, based on our analysis in Excel, let's see the full thing, making it a bit smaller here. So I hope you can still read that. It's getting very small. So based on our analysis, we found that the payback period, yes, it is quite close to the useful life of the investment. However, we have found that the net present value is positive. The internal rate of return is quite high. It's higher than the rate of return, the required rate of return. So we would decide to go for the investment, and yes, Spring Experience should purchase a new window cleaning machine just based on these numbers. Of course, in practice, you would consider other factors as well, such as follow-up investments, further use of such a machine, also non-financial considerations. So it is very important to take these into account as well. But if we're limiting to just these numbers, then yes, they should undertake the investment. Very well. Well done. Don't forget to save the file, and